Hey guys, Mr. Fransky here. Today we're going to talk about some more trig equations. We've kind of done some basic things like cosine x equals 1/2, and then we found the spots on the circle where that's true, so here and here. And then we said, okay, that's pi over 3 plus 2 pi n, or 5 pi over 3 plus 2 pi n. And now we're just going to expand on this with multiples of angles and factoring, and we're going to do that actually in the opposite order. But let's take a look and see what we find. So first thing, if you want to try this for above work, you can pause the video and give it a shot. Just the difference between what an identity is and what it is to solve an equation. So if you want to pause and give it a shot, go ahead. All right, let's try them together. So the first one, we're proving an identity. Remember, that's true for all values of x. So this is like a proof. So we're going to start from one side. I'll probably start with the left, and we're going to try to get it to the right side. So cosine x minus y, that is cosine, cosine, sine, 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 divided by cosine x sine y, cosine y, excuse me. Now we can split that up across that negative sign. It's a heart, so we break it apart. So that is cos x, cos y over cos x, cos y, minus sine x sine y over cos x, cos y. Well, this is 1, and this is sine x, tan x, tan y. Which is what we're going for. Cool. Now an equation, this remember, is going to have some values of x that work. So we're going to isolate the tangent. So we're divide by 3. So we have tan squared equal to 3. That means that tan has to be plus or minus root 3. So tangent is root 3, that's the longest value. Pi over 3, also at 4 pi over 3. Pi over 3 plus 2 pi n, or 4 pi over 3. Plus 2 pi. Now the pro way to do that, we could have just said pi over 3 plus pi n. But I'm going to leave it like this because that's just fine. Now we have 4 sine x plus 2 equals 0, so I have 4 sine x. Oops. So we have 4 sine x is equal to negative 2. So sine x is negative 1/2. Sine x is negative 1/2 here and here. That is at 7 pi over 6, so plus 2 pi n, and 11 pi over 6, plus 2. So if you have any trouble with these, you're going to want to look at some previous screencasts. The trig proofs ones for the identities, and then yesterday's the intro to trig equations for B and C. All right, let's try something new. So nonlinear solving. So if you're given 2x squared minus x minus 1 equals 0, we have 3 ways we can solve this. One is quadratic formula. One's completing the square. And one's factoring. That is definitely my favorite. I just think it's the easiest. So we've got a quadratic set equal to 0. So we got 2x and x to make 2x squared. And then we need 1 and 1 to make 1. Looks like we need negative 2x and positive 1x to make that work. So either 2x plus 1 equals 0, or x minus 1 equals 0, because of zero product property. Well, if x minus 1 equals 0, x is 1. Or, looks like over here, x could be a little math in my head, negative 1/2. Okay. So let's try that adding trig. So we throw some trig in there. Let's see here. We still have a quadratic. Let's see if we can get everything on one side. So I want positive, so I'm going to move everything to the right. So 0 equals positive 2 cosine squared x minus cosine x minus 1. Now, we can do u sub here. 2u squared minus u minus 1. Factor that. Got 2u and u. 1 and 1. So we're going to negative here for negative 2, and then a positive 1 will bring us back to negative u. Now put the cosines back in. So this is 2 cosine x plus 1 times cosine x minus 1. So that means that either 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. Well, in this case, cosine would have to be negative 1/2. And here cosine would have to be 1. Cosine is only 1 at the right side. So that is just 0 plus 2 pi n. And cosine is negative 1/2 here and here. That's at 2 pi over 3 and 4 pi over 3. So 2 pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n. Now you might have noticed that this equation that we ended up with here is exactly the same as the last one we did. And really that's kind of the point, is that a lot of these you just end up having to factor as if they were x's or u's. And then you can do the final piece just like we did with the trig equations yesterday. So not too bad. Let's have you guys give this a shot. So why don't you try this? We're going to try to factor this guy, and then see if you can find the values that we need x to be to make this whole thing 0. Alright, let's give it a shot. So they all share a sign in common, so I'm going to take that out right away. So I have sine squared x plus 5 sine x minus 3 left. And now we can factor that guy. So we have sine x. And I'm just going to do it without changing to use this time. So we got 2 sine x and sine x. And then 3 and 1. Let's see here. I need the 3 here to make a 6 sine x, and a 1 here to make a sine x. And it looks like those are both, let's see, we're going to have positive 6 and then negative 1. That'll work. So I got 3 options. Sine could be 0. 2 sine x minus 1 could be 0, or sine x plus 3 equals 0. So if sine x is 0, that only happens at 0 pi. So we have 0 plus 2 pi n, pi plus 2 pi n. Now let's see here, 2 sine x minus 1 equals 0. We need sine x to be positive 1/2 then. Happens here and here. So we got pi over 6 plus 2 pi n. And 5 pi over 6 plus 2 pi n. And our last one, sine x plus 3 is 0. Sine x equals negative 3. Now that's weird, because the biggest sine can be is positive 1, and the smallest it can be is negative 1. So this actually doesn't help us at all. It doesn't give us any solutions. Alright, so these 4 will be the solution to this problem. 0 plus 2 pi n, pi plus 2 pi n, pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi. Alright, moving on. So, factoring, not too bad. This guy's also a factoring problem. If you want to try it, you can pause the video. Go ahead. Alright, so for this one, the key is that I've got sine here, but not here. But 1 minus cosine squared by Pythagorean is sine squared. So I have 4 sine to the 4th x minus 5 sine squared x plus 1 equals 0. Now, we can factor. So, u is going to be sine squared x. So then, think about this for a second. What is sine to the 4th x? And the key is that sine to the 4th x here would be sine squared again, which would be u squared. So, here we have 4u squared minus 5u, because u is sine squared, and then plus 1 equals 0. And factor that, 4u and u. Looks like we need a 1 and a 1, and they're both negative, because a negative 4 and a negative 1 equals 0. So now we can bring our u back in, so we have 4 sine squared x minus 1 equals 0, or sine squared x minus 1 equals 0. Let's do with the right one first, it's a little easier. So I got sine squared x equals positive 1. So sine could be, I think that it has to be, square root could be plus or minus 1. Okay, so sine is plus and minus 1 at the top and bottom of the circle. So that is pi over 2 plus 2 pi n, and 3 pi over 2 plus 2 pi n. And then over here, let's see, we would have sine squared x is going to be 1/4. So that means sine x is plus or minus 1/2. And that happens, we had this in the last problem, here and here. Pi over 6, so plus 2 pi n, and then 5 pi over 6 plus 2 pi. That's all there is to it. So we're getting 4 solutions here. That happens a lot. Could do this the pro way over here. Pi over 2 plus pi is 3 pi over 2 plus pi brings you up to the top. You just keep going around. Cool. Alright, let's take a look at a different type of problem. So here we have sine 2x minus cosine x equals 0. Now I'm going to use an identity here. Sine 2x is 2 sine x cosine x minus cosine x equals 0. Now this shares in common cosine x, so I'll pull it out. We're left with 2 sine x minus 1 equals 0. Cool. Okay, so cosine x could be 0. We have so many c's there. Let's get rid of 1. So cosine could be 0. That happens at the top and bottom of the circle. Or 2 sine minus 1 could be 0. So in that case, sine would be 1/2. Sine is 1/2 here and here. So that is, let's see, pi over 6 plus 2 pi n. And over here would be 5 pi over 6 plus 2 pi n. Cool. The key to these problems is really you're going to factor. And then when you have two things multiplied together that make 0, one of those two things has to be 0. And then you just take your answers, add plus 2 pi n, and you're off to the races. That's really all there is to it. So here, I guess I should write the other solution. So cosine is 0 at pi over 2 plus 2 pi n, or 3 pi over 2 plus 2 pi n. Well, all of these, I guess, are solutions I should circle off. Nifty. All right, something even more different. Multiple angles. Now, this is something that confuses people every year, but if you just pay attention, watch what's happening, you're going to be okay. So cosine 2 theta equals root 3 over 2. So what's happening here is there's some angle that when you double it, the cosine of that angle will make root 3 over 2. The way I do it is I ignore this for a second. So just for a second, we're going to pretend that it's just an x. So if it was cosine x equals root 3 over 2, think about where that happens. That happens at pi over 6, that's the long cosine value, and 5 pi over 6, the long negative cosine value. So what I know is that 2 theta either has to be pi over 6 plus 2 pi n, or 2 theta has to be 5 pi over 6 plus 2 pi n. So now what I'm going to do is I'm going to take this solution. So I know that if any pi over 6 plus any multiple of 2 pi, if that is a 2 theta, then cosine of that value will be root 3 over 2. So what I'm going to do is I'm just going to divide by 2. So this guy gives me theta would be pi over 12 plus pi n. Very important that you also divide the period by that number. Okay. So or theta could be 5 pi over 6 plus anyone with 2 pi n plus pi n, because we're dividing by 2. So those are our two solutions. That's really all there is to it. So solve first, then your last step will be to divide or multiply. Let's try this one. So we got 2 sine of x over 2 plus 1 equals 0. So we'll isolate the sine x over 2. So I have sine of x over 2 equal to negative 1/2. So if you think, okay, where is sine negative 1/2? Forget about the x over 2 for a second. That's it, 7 pi over 6 and 11 pi over 6. So we know x over 2 could be 7 pi over 6 plus 2 pi n, or x over 2 could be 11 pi over 6. Let's say 4 seems too small there, plus 2 pi n. So now what we're going to do is multiply by 2. So we have x could be 14 pi over 6 plus 4 pi n, or it could be multiplied by 2. We'd have 11 pi over 3, and then plus, this would be 4 pi n. Yeah. And you have your solutions. And that's all there is to it. Not real complicated, but it takes some practice. So that is the end of the chapter. We've finished chapter 5, finally. The white packet is going to be your homework. There's all kinds of double angle formulas and stuff there. If you're out of town or gone, please do take a look at that. We'll be reviewing next week for the test. Otherwise, I love you guys. That's why I'm here, and have a great day.